Hi everybody, so we are now moving on to our next lesson, and that is going to be about compound inequalities. I'm sorry, the camera is covering the title. All right, and so our goal for today will be to, let me bring that back up there, okay. Solve and graph inequalities containing the word and then the other goal will be to solve and graph inequalities containing the word or. All right. So let's have basic terms first to start with. So when we talk about compound inequality, it consists of two distinct inequalities. And those inequalities are either joined by the word and or by the word or. All right. And we'll discuss some differences later on. Inequality with the word and. It contains the overlap of the graphs of the two inequalities that form the compound inequality, okay? So this is an example of an inequality with the word and, okay? So x is greater than or equal to 3 and x is less than or equal to 7. So greater than or equal to 3 is anything to the right of 3. Less than or equal to 7 is to the left of 7. And so you will see that the overlap of these two graphs happens between 3 and 7. So that's how the graph of an inequality with a word and looks like. All right. So the next one up is if we have the inequality with the word or. Okay. So it contains each graph of two inequalities that form the inequality. Now in this case, you will see that with the word or, so let's say you have this example here, you have less than -2, so to the left of -2, greater than or equal to +1, so to the right of -1. So if you combine these two graphs, there is no overlap at all. They are like individual graphs of it, okay? So one technique that you would like to remember is that when you have and, okay, they get connected. All right. If you have the word or, they are going in two different directions. Okay. So let's start with some example problems here. So we will be writing, so what is the compound inequality that is represented by the phrase, and graph the solution. So all real numbers that are greater than -2 and less than less than 6. All right, so if we are going to write this down, we will have x need to be greater than, let me keep that away first, greater than -2, and okay, x need to be less than +6. So if you will have your number line, again, pardon my very straight line in here. So -2 is over here on the left side. +6 is here on the right side. And if we are going to graph those numbers that are greater than -2, it is going to be a hollow dot on -2, and it is pointing to the right, okay? All of those greater than that. Now for the less than 6, are going to be hollow dot on 6, and it is going to the left. So as you can see, those arrows will meet together, all right? And so the graph will eventually be something, let me see, where is my line over here? There it is, finally, okay? So they will get connected, again, pardon the straight line. Oops, my bad. Let me erase that. Okay, so you will see here that the line will get connected to each other. Okay, so these two over here, oops, let's just try our best. There we go. That's how the graph of all real numbers that are greater than -2 and less than 6. Okay, so now we have or. Okay, so if you would like, we can go ahead with the graphing already. So let's have this example. So we will have our number line here. Oopsies. Okay, so we have 0, is over here, and then 5 is the other reference number, okay? Less than 0, so it is going to be a hollow dot on 0, and it's pointing to the left. Greater than or equal to 5 is going to be a solid dot on positive 5, and greater than are all to the right. And so you will see that the graph will be pointing on different directions. Okay. So how do we solve compound inequalities? Now, if you would remember, when we were doing solving inequalities, all we need to do is to isolate the variable. Now, in this case, it's going to be the same thing, only that what you will notice is our variable is in the middle. All right, so you can see here, negative 3 is less than or equal to m minus 4 is less than negative 1. Okay, so let me put back the camera up here. So when you have a compound inequality, whatever you do in the middle to isolate your variable, you have to also do it on the two sides. Okay, so let's have this example here. So our goal is to isolate our m, correct? So how will we do that? Now, as you can see, m is connected with a minus 4. So we need to get rid of that minus 4. How do we do that? We add positive 4. So whatever you do here in the middle, okay, you also have to apply that to both of the sides. So we're going to add positive 4 over here. We're also going to add positive 4 in here. Okay, so now what is our middle expression? Negative 4 and positive 4, it will just be m now. Okay, and then of course we have our two inequalities, they stay the same. Negative 3 and positive 4, that's a positive 1. Negative 1 and positive 4, that's going to be a positive 3. And so m, okay, how are we going to graph this? All right, now you know that when we have compound inequalities, we will have two or more inequalities, okay? So let's get one part first. Let's have this part over here. Where is my mouse? There we go, this part first. Okay, so that is 1 is less than or equal to m, but again, we cannot graph it that easily if our m is in the right side. So we switch it to the other side. So this is now going to be m is greater than or equal to 1. So that is one part of the inequality. The other part, okay, the second inequality is going to be this one over here. Oops, I'm losing my pen again. Okay, there we go. It's going to be this side. Now that is very easy to see because it is simply m is less than 3. So if you are going to graph it now, so let me switch my ink here. So you will have positive 1 and then positive 3, okay? You have a greater than or equal to positive 1, so it's going to be a solid dot on positive 1, and it's going to the right. As for 3, it's a less than, so it's going to be a hollow dot on 3, and it's going to the left. And so you can see that they will get connected. So that's how the graph would look like, okay? So why don't you try this next example on your own? Go ahead. All right, so you will see here that you have a 3y minus 4. We have to isolate the y, so we add 4 on all sides. We divide by 3 on all sides, and so our inequality will be 2/3 is less than y is less than 6. And so it will be a graph wherein you have two hollow dots that meet together, okay?